With this session, we are going to discuss about effect of atomic radius. As we discussed in previous session, while we move across a period, atomic radius value get decrease, and while we move down to group, atomic radius value get increase. There are some elemental properties which are affected by value of atomic radius. Here with this session, we discuss about the same. Now first, while we move across a period from left to right, there are certain elemental properties which get changed across a period. Like as we know, atomic radius value get decreased across a period. So it means their attraction between nucleus and electron it becomes strong as per we move across a period. If such attraction becomes strong, element not allowed to lose electron from their outermost cell easily across a period, because if attraction is strong, they require huge amount of energy to lose electron, and that is why they allow to gain electron as per they move across the period. If some element allow to gain electron, it means their non-metallic character become strong, and such element who gain electron they are called electronegative element. So this is the first property which affected due to the atomic radius size get decreased across a period. Its non-metallic character. As per we move across a period, non-metallic character of element becomes strong. Means elements allowed to gain electron, not lose. So non-metallic character becomes strong and metallic character become weak. Next property on the basis of energy. While any element allowed to gain electron, there are some energy change occur. This energy change to from neutral atom to get convert as anion, electron negative ion after gaining electron. This energy change is called electron affinity. As per elemental non-metallic character or electronegative property becomes strong, the value of electron affinity is also increased because their nature of on the basis of negative charge becomes strong, so energy change occur between neutral to electronegative element, that is also become more strong. So while we move left to right in a period, their electron affinity value also become strong. Here you can see lithium in second period, the first element this has one electron in their outermost cell. Here its atomic radius value is 152 nanometer. Now next one is beryllium. It has two electrons, and due to this attraction becomes strong between nucleus and outermost cell electron. And here its atomic radius size is little bit get down as compared to lithium. Its atomic radius value is 112 nanometer. And if attraction becomes strong, their metallic nature is little bit get down as compared to lithium, and non-metallic character moves up. And energy value, energy change occur in between to gain electron that becomes strong. So this such kind of changes occur due to atomic radius value get changed across period. Now next one, across group. While we move top to bottom in group, here number of cells get increased, and as we discussed in previous session, the atomic radius value get increased. If atomic radius value get increased, it means distance from nucleus to outermost cell that become increase. And if distance get increased, the attraction become weak. And attraction become weak, it means they easily allow to lose electron from their outermost orbital. And if such element allow to lose electron, it means it not metal, so it's considered as their metallic character becomes strong, and such elements are considered as electropositive elements because they allow to lose electron, and on such elements the positive charge value become more strong. In this, consider as while we move left top to bottom in group, their metallic character becomes strong, and as per metallic character becomes strong, it means their non-metallic character become weak. Now next change on the basis of energy. When any element allowed to lose electron from their outermost orbital, it requires some amount of energy. This energy is called ionization energy. The energy needed to remove an electron from an atom. If I say, while we move top to bottom in a group, element allowed to lose electron easily, it means the requirement of energy it become decrease. If energy requirement get increase, it means they're very difficult for them to lose electron. If they easily allowed to lose electron, it means the requirement of energy it become decrease. So while we move top to bottom in a group, the requirement of ionization energy it become decrease. Like you can see here. Here you have lithium. It have one electron and has two cells. Now second one, sodium, if you see, it also have one electron in the outermost cell, but it has three cells across the group. Now distance from nucleus, sodium have more distance as compared to lithium. So here sodium can easily lose electron as compared to lithium. It means sodium is more strong metallic nature as compared to lithium. So we can say while we move down to group, their metallic character becomes strong and non-metallic character become loose. And on the basis of energy, if we'll consider, sodium require less amount of ionization energy as compared to lithium, because here it's have more distance, so with the little amount of energy it can easily lose electron, and it require more amount of energy as compared to sodium. So here while we see in this picture, here while we move down to group, metallic character becomes strong and non-metallic character become weak. And requirement of ionization energy and as well as electron affinity, because electron affinity is completely based on non-metallic character, and here non-metallic character become decrease, it means electron affinity value also get decrease. Now if you consider the across a period, completely oppose from group, non-metallic character becomes strong, electron affinity power becomes strong. If non-metallic character becomes strong, it means metallic character become weak. And if metallic character become weak, it means ionization power it's become strong. With this note, we conclude the session. We'll see you in next session.